Our today's lesson is solving linear systems by substitution. Alright, for example, solve the following system using substitution. We have x equals 3 and x plus y equals 5. Well, the line x equals 3 tells you what the x-coordinate is. So x equals 3, we know that's part of the intersection. And all we need to do is solve for y. And a lot of students get confused as they say there's no y in the first equation, but there is. You have x plus 0 times y equals 3. And 0 times any number is 0, so that's why you just see x equals 3. But you can take that and substitute that to the bottom equation. So if x is 3, you got 3 plus y equals 5. And if I subtract 3 to both sides, that tells me that y has to equal 2. Alright, so the intersection is 3, 2. Alright, solve the system y equals 2x and 4x plus y equals 24. Well, notice that y equals 2x. So I'm going to take 2x and substitute that in for y in the bottom equation. So I have 4x plus 2x equals 24. Now I have an equation, one variable. So 4x plus 2x is 6x. I divide both sides by 6. X has to equal 4. But now for y, I can plug it into that top equation because it tells me y is twice whatever x is. So I have 2 times 4, which means y has to be 8. So the intersection is 4, 8. Alright, solve the system y equals 12 minus 2x. 3x minus y equals 3. Y is equal to this expression 12 minus 2x. So we're going to substitute that expression into the bottom equation for y. So I have 3x minus the quantity 12 minus 2x equals 3. And be careful with this subtraction sign. You're going to distribute that negative throughout the parentheses. So that's going to change the sign of every term in the parentheses. So I get 3x minus 12 plus 2x equals 3. And then you want to add like terms. So I have 3x and a 2x. That's going to give me 5x. Minus 12 equals 3. If I add 12 to both sides, I get 5x equals 15. I divide 5 to both sides. That tells me x has to be 3. Alright, and to get the y term, I just substitute this value into the expression that the top equation because y is already by itself. So I say 12 minus 2 times 3. So 12 minus 6. So y has to be 6. So 3, 6 is a point of intersection. Alright, solve y equals 2x minus 1 and 3x plus y equals 19. Again, you have the y by itself from the top equation equals to 2x minus 1. So we substitute that expression into the bottom equation for y. So 3x plus 2x minus 1 equals 19. We're going to add like terms. So 3x plus 2x is 5x minus 1 equals 19. The opposite of negative 1 would be positive 1. So I get 5x equals 20. Divide both sides by 5. X is 4. All right, and you want to substitute that to the top equation. So y equals 2 times 4 minus 1. 2 times 4 is 8. 8 minus 1 is 7. So 4, 7 is the point of intersection. All right, let's solve the system 3x plus 2y equals 19 and x plus y equals 8. Now notice in this situation, we don't have x or y by itself. But if you look at the bottom equation, you have coefficients of 1 for x and y. So that makes it easier to solve for either x or y and substitute it into the top equation. So let's say I solve for x. I just simply subtract y to both sides. This means that x has to equal 8 minus y. And I'm going to substitute that into the top equation for x. So I have 3 times 8 minus y plus 2y equals 19. 3 times 8 is 24 minus 3y plus 2y equals 19. So negative 3y plus 2y is negative 1 or negative 1y equals 19. And I'm going to subtract 24 to both sides. So negative y is going to equal negative 5. And what I can do is multiply or divide by negative 1. So that tells me that y has to equal 5. And since y is 5, I'm going to substitute that into my expression here. X equals 8 minus y. So x equals 8 minus 5, which means x has to be 3. So 3, 5 is the point of intersection. This concludes our lesson for today.